Hello everyone, my name is SN Patil. In this video lecture, we will discuss the topic line integral. Here, we find the line integral of the independent path. The path is not mentioned, just mention the 2 point. Okay, it means the path is independent. How we can solve this independent path? So first of all, we check this field, this vector point function, whether it is a conservative or not. If this if this f is conservative means what? If the curl of f bar is 0, it means f bar is irrotational, that is the f is conservative. Then the line integral f bar dot dr bar is equal to phi of b means upper limit minus lower limit. Okay, so what is phi here? The phi is scalar potential function. We know that if f bar is conservative, then there exists scalar potential function phi such that what? Such that f bar is equal to gradient of phi. Then we find this phi using total derivative formula. Otherwise, using the formula phi is equal to integration f1 dx. Here y and z constant plus integration f2 with respect to y, z is constant and free from x term, means term not containing x. And the last integration f3 with respect to z free from x and y term. Okay, plus integration constant. We use this formula for finding the phi. Okay, let us proceed. So here the f bar is equal to, let f bar is equal to given function. So first we check whether it is a conservative or not. We consider the curl of f bar is equal to the first row default I, j, k. Okay, the second row is component of this del. Del is vector differential operator having component partial derivative with respect to x, second component with respect to y, third component with respect to z. And the third row is component of f bar, that is the first component 2xy plus z cube, third component x square, and then third component 3 times x z square. Okay, now let us solve this determinant. The determinant is solving, we find the minor of I, which is obtained by deleting row and column. The derivative of this term with respect to, see the derivative of this term with respect to y. So y is not here, the partial derivative with respect to y. The other are constant, so its derivative is 0 minus the derivative of x square with respect to z. The x square is constant for the z, that is 0 minus minor of j, deleting row and column. The derivative of this term with respect to x, that is 3 times z square, minus the derivative of this term with respect to z. There are two terms. The first term whose derivative is 0 because z is not there. Now z is present. Now its derivative of z cube is 3 times z square. Now last, the minor of k, deleting row and column, the derivative of this term with respect to x, that is the 2x, minus the derivative of this term with respect to y. 2x is constant, the derivative of y with respect to y is 1, and 2x is multiplied to the 1 plus derivative of z cube is 0. So here we get this first term is 0, second is 0, third is 0. So we get the null vector, that is the curl of f bar is 0. It means f bar is conservative. Otherwise, you can also say f bar is irrotational. F bar is conservative. Okay, if f bar is conservative, then the line integral f bar dot dr bar over this path C is equal to phi of upper limit. Suppose upper limit say B minus lower limit A. So here A is lower limit, say 1, 2, 1 minus 2, 1. Okay. And the B is 3, 1, 4. See here, I'm putting direct limit 3, 1, 4 minus lower limit 1 minus 2, 1. Suppose this is equation number 1. Okay, let us find the phi. Since del cross F bar is 0, there exists scalar potential phi such that the vector field is same as the normal vector gradient of phi. Okay, both are the parallel. So from this relation, we find the phi. The phi is equal to integration. Okay, suppose this F bar we denote as a F1I, the coefficient of I is F1, F2J, and F3K bar. Then the integration of F1 with respect to X. Here, YZ treated as constant plus integration F2 with respect to Y. Here, Z treated as constant and the term not containing X, that is the free from X term, plus integration F3 with respect to Z, free from X and Y term, and plus integration constant. Okay. Now phi is equal to F1. F1 is coefficient of I. That is 2xy plus z raised to 3 dx, plus F2 is a coefficient of j, but here we want the term not containing x. So here x is present, so there is no term. Okay, say 0 term. Now plus integration of F3, and which it should be a free from x and y. So here x is there. So there is a 0 term and plus integration constant. Okay. Now let us solve the phi. Phi is equal to the integration of x, 2 and y is constant, is x square upon 2, 2 will get cancelled. That is x square y plus z cube is constant with respect to x integration, that is z cube x and plus integration constant. So this is the phi. Okay. Now let us find the phi of 3, 1, 4 and phi of 1 minus 2, 1. Okay. Now first I am finding the phi of A, up lower limit A. A means what? 1 minus 2, 1. So here it means substitute x is equal to 1, y is equal to minus 2 and z is equal to 1. That is 1 square minus 2 into 1 cube into 1 and plus c. So here we get, this is minus 2, this is the plus 1, we get minus 1 plus c. Minus 1 plus c. Okay. Now upper limit phi of b. We consider b is equal to 3, 1, 3, 1 and 4. That is phi of 3, 1, 4. So substitute here x is equal to 3, that is 3 square y is equal to 1 plus 4 cube into 3 plus c. So this is 9 into 1 plus this is the cube, that is 64 into 3, that is 192 plus c. So here we get phi of b is equal to 201 plus c. Okay. Now put phi of b and phi of a in equation 1. Put in equation 1 the line integral f bar dot dr bar along the path c is equal to 201 minus, 201 plus c. This is the upper limit minus 1 plus c. Here minus plus c will get cancelled. So we get 202. Okay. Suppose if we solve this integration using the straight line formula, we know that suppose this is the x1, y1, z1 and x2, y2, z2. That is x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1 is equal to t. Okay, if we solve this problem using this formula, then it will take too much time. So instead of that, if the path is independent, find the curl of f bar is 0, then apply the formula phi of b minus phi of a, and for finding the phi, use this formula. Okay, thank you. Thanks for watching the video.